we have an equilibrium of a mixture of pcl5, pcl3, and also Cl2. And all of it, they have partial pressure of 217 torr, 13.2 torr, 13.2 torr respectively. And then another excess chlorine gas is going to inject in the mixture. And the total pressure just before the before everything to re-establish the equilibrium, it will be 263 torr. So, and then we allow the system to equilibrate. So, and the appropriate chemical reactions is pcl3 plus Cl2 to pcl5. So I'm going to copy and paste that. So we have pcl3. Yeah, there's something wrong with that. All right, so we have pcl3 with gas. We're going to mix with chlorine gas, and they're going to form pcl5. All right, so I'm going to put a gas over here. Okay, so we're going to calculate the new partial pressure after equilibrium we established. All right, so maybe I move it a little bit so we have a little more space on the on the screen on the right. Okay, so let's go through the answers part by part. Okay, so yeah, we already have an equation given over here, and I forgot that it's equilibrium, so I should have a double arrow. So initially, we can calculate the Kp, and we are going to take the initial initial pressure, plug in the Kp expression. All right, so I would like to just write out the Kp expression. So we know that the Kp expression will be equals to the partial pressure of our product over the partial pressure of our reactant multiplied together. So this will be the expression of our the equilibrium constant in pressure. All right, so yeah, we just plug in a number. It's not that difficult. It's 1.2454. Yeah, and this is right. Yeah, this is definitely right. Okay, so after adding the chlorine gas, we know that it will be PCl5 will be 217, and then PCl3 will be 13.2, and then chlorine will be 13.2 plus X. Okay, so we know that the partial pressure will be, actually the total pressure after adding chlorine will be 263. So yeah, so we are going to add everything together, and also we just don't know how much is going to of chlorine gas is going to add. So that's why we let it at X. So from here, we add everything together, including the excess chlorine gas, and then we are 263. So from here, you can solve for the equation, and we should be find that the total pressure will be 19.6 torr. It's being added to the equation. Sorry, the reaction. Okay, so from here, it's just kind of confusing, I think, from the solution over here. So maybe we just go step by step. Okay, so when we go back to our reaction equation over here, we have an equilibrium. So for equilibrium, we can look at Le Chatelier principle. So we have PCl3, we have chlorine, and then we have PCl5. Okay, so from here, imagine we increase the amount, the pressure of chlorine gas. So what will happen to the equilibrium? So we increase the amount of reactant, and the equilibrium, we want to re-establish a new equilibrium position by removing the excess chlorine gas. So the whole equilibrium will shift to the right. All right, so if we are going to write our ice table, so I am going to go down a little bit. So we want to write our ice table. Okay, so first of all, we have 217 PCl5, but we add in more. We will add in more chlorine gas. So we are expecting the PCl5 going to increase, but the Cl2 and PCl3 are going to decrease. So therefore, we are going to set the ice table. When we set the ice table, the initial condition will be the one just after adding the chlorine gas. Okay, so from here, we know that the chlorine, the PCl3 will be 13.2 torr. And then for the chlorine gas, we will have 13. Let me look at that. 13.2 plus 19.6. If you see that on the left, we already have 19.6 of chlorine being added. Okay, so if you do the math, you should be able to find it around it will be 32.8. 32.8. So I'm going to change it to 32.8. Okay, so again, by Lecher principle, we know that the reagent we are going to decrease in order to remove the excess chlorine, and then we're going to have more of our pcl5. So at the end of the day, we are going to establish this equilibrium concentration. Okay, so the next step, we will just plug in everything here back to our equilibrium constant expression. Okay, so we are going to back to our the solution on the left. That's exactly what is going on. So we are going to plug in the expression, and then we are going to solve for that. It takes some time, but it's a very simple algebra. We are going to solve for that as a quadratic equation, and you should be able to find that the x will be equals to either 6.4 or 40.4. Oh, but for this case, we're going to ignore 14.4. The reason is that x cannot be bigger than 30.2. If so, then we don't have any pcl3 left. And for this case, it is not reasonable. It should not be happen. So that's why we're going to choose 6.4 as our answers. And then we just plug in 6.4 as x, and then we can find out the pcl5 will be 217, pcl3 will be 6.8, cl2 will be 26.4. Okay, so for my comment for this question and solution is that the solution is correct. However, the solution is kind of confusing. Especially, you can see that because the solution didn't show using an ice table. If an ice table is used to find out the equilibrium concentration, actually it's equilibrium pressure. This would be more easier to explain. Okay, so this will be the second question on equilibrium. So this is correct, so we can keep going on.